Hi, IB. We're going to go ahead into the second to last section that has to do with applications for this chapter. So we are starting to put to use all of the skills that we learned solving quadratics. We're now going to practice problem solving with them. So think back to when you first learned how to solve word problems. We want a clear picture. We're going to need to write an equation to represent whatever the picture is showing. It might be a formula, it might be something we're familiar with, or we might just make up our own. Then we're going to solve it with a method that's suitable for the problem. And you always want to check your solutions to see if they're reasonable when you're talking about a real life problem. For example, if you have length or area, we can't have negative values. You guys know that. And if we're talking about the number of items or people, we want to make sure we have integers as our answer, right? So just think about in context of the problem what your answer is actually telling you. And then we do want to write our answer as a sentence in the end. So take this first example. The length of a rectangle is 4 centimeters longer than its width, and the rectangle has an area of 26 centimeters squared. We're supposed to find its width. So I've got a rectangle here because we do want to start with a clear picture. So I'm going to label my rectangle. I can choose any letter, but it says the length is 4 centimeters longer than the width. So I don't know how wide this rectangle is, but I know that the width is 4 centimeters longer. So I'm going to go ahead and label what I've been told in the problem. Since we're talking about area, I know the equation I'm going to use is going to be the area of a triangle. So for me, area is length times width. So length would be W plus 4, and my width will be W. And I've been told that in the problem, this area is equal to 26. So what I'm actually looking at is 26 is equal to W squared plus 4W. Now, we already can notice that this is a quadratic. I have the square, I have a W, here's my A value, and my B value is 4, and my C value is over here. So in order for me to solve this, I'm going to have to set it equal to 0. So 0 is equal to W squared plus 4W, and if I subtract the 26, I now have my quadratic in standard form. So the question is, what are the different methods that I can use to solve this? For me, I'm noticing I can't think of two factors that multiply to negative 26 and add to 4. So let's go ahead and begin by completing the square. So I'm going to keep my W squared, and I'm going to look at this middle term, and I'm going to go ahead and separate that. So plus 4W. Half of 4 is 2, squared is 4. So the term that I want to add in is 4. So that means I also must subtract, there we go, squeeze it in, a 4 outside of my brackets. So now I'm looking at, this comes down to W plus 2 squared and minus 30. So when I wind up solving this, I'm going to have 30 square root of 30 plus minus the square root of 30, and that will equal W plus 2. So then W will be negative 2 plus or minus 30, root 30. Now if I'm considering the two answers that this gives me, I'm either considering that W can be negative 2 minus root 30, or W can be negative 2 plus root 30. Now, if you guys consider, we're talking about the width of a rectangle. If I have negative 2 minus root 30, that's going to give me a negative answer. So I'm going to take that one out immediately, and I'm going to find my answer for negative 2 plus root 30, or the equivalent decimal. So I can have an approximate width for my rectangle in centimeters. All right, so the width of this rectangle is 3.48 centimeters. Remember that IB, you guys are just beginning to realize that IB always suggests to leave an exact answer or 3 significant figures. So I'm going to leave my answer as 3.48 centimeters, and I'm writing my full sentence. So we've gone through all 5 steps. of solving this problem. Looking at our next example, we are going to look at this open box where basically you are given one sheet of, what is this, tin, I guess. That's the corners have been cut out and they've been folded upward, and then you get a basically like a tin box that you could fill up with whatever you wanted to. So it says the open box can hold 80 centimeters cubed. So automatically I'm thinking we're going to need to talk about volume. Okay, and I know the volume of a rectangular prism is length by width by height, so I can also write that down to remind myself. Secondly, it says that there's 3 centimeters that are cut from each of the 4 corners. So what we're really looking at is that if this entire side of the original tin plate was X, then this smaller portion that is now left over once you cut out the 2 corners, and they're all equivalent, they're all 3. If I cut that out, I really have a length of X minus 6 centimeters. So that is now the side length for all 4 sides once they're folded up and cut out. So I'm looking at, if I wanted to actually write an equation for my volume, since it says it's 80, that's the only information they've given us. I know that my volume is needed to be used here. So the length is going to be X minus 6. And the width is also X minus 6. And if you think about the height is that little piece that's been folded up, which is exactly how much you cut out. So that's actually 3. So at this point, I would try to expand this and see what method you might use to then solve this equation when you set it equal to the 80 centimeters that you were told the volume actually holds. So expanding the first 2 binomials, we get x squared minus 12x plus 36, and then I still have to multiply through by 3. And I have that 80 that's left on the other side. But notice here already, I'm noticing that I have the x squared minus 12x plus 36, and half of 12 is 6, and 6 squared is 36. So I have a perfect square with these 3 terms. So at this point, I could also just divide by the 3 instead of multiplying through by the 3. And if I divide by 3 on this side, I wind up having 80 divided by 3, and then this factors into x minus 6 times x minus 6. So I actually have a perfect square. So I can skip one step of completing the square if I do it this way. If I have 80 divided by 3, that equals x minus 6 squared. And if I didn't realize that, I could have multiplied through by 3. I could have subtracted the 80 over and then started a method that I could figure out. But this is going to help us go a little bit faster. So now I'll take the square root. And again, I'm considering what my answers might be here. So x is going to be 6 plus or minus the square root of 80. So go ahead and decide, is it going to be that you have 6 plus the square root of 80 divided by 3? Or will you wind up having 6 minus the square root of 80 divided by 3? Go ahead and pause here and see what you guys come up with. When you're considering your 2 answers, notice that if they're both positive, so we can't always just go on whether they're negative or positive when we're talking about length. Because if one side were 0.836 centimeters, remember we cut out 3 centimeters from each corner. So that would not work. We need to have something that's bigger than at least 6, right? Because we cut out 6. So 11.2 is going to be the answer that we go with for this question. So let's go ahead and write up our sentence. So the original dimensions of that tin plate were 11.2 centimeters by 11.2 centimeters, since it said it was a square. All right, guys, last but not least is number 10. Again, these are all examples from your textbook that we have not assigned to you. And they're also different from the blue box examples in your book, so that way you guys have more problems to follow as examples, so you guys can do your work. But for this one, is it possible to bend a 20 centimeter length of wire? Automatically, we know something that the length of wire is bending to make this shape. So if it's bending to make this shape, that means that that is going to be the perimeter. So I know something about the shape already. We have the perimeter is 20, and we want to make a rectangle with area of 30 centimeters. So we have something about the perimeter, and we've got some information about the area. I have a picture. I'm going to label my picture, though. They don't tell me what the length and the width are, so let's just label our length and our width. I'm going to call them x and y in this problem. Then I need to write an equation. Well, I actually have two separate equations. I know that my perimeter is going to be 2x's plus 2y's. And I also know that my area is going to be x by y. I also have a value for my perimeter of 20 centimeters. And I also have a value for my area of 30 centimeters squared. So I actually have enough information here to isolate either my x or my y, and that's just by making one equation out of two equations, which is just really solving a system of equations. So let's try that. We have, I'm actually going to isolate this second equation because it looks simpler. It has less terms. So let's do that. If I had 30 equals x by y, then I could basically replace y and say that it is 30 divided by x. So now I will use that, and I'll replace my y in the first equation. So I know that I have 2x plus 2y to make 20. So that y is going to be 30 divided by x. That leaves me with 2x plus 60 divided by x equals 20. And now we're going back to what we did in the first few sections of this chapter. I need to make this look like a quadratic. So I'm going to multiply through by x in order to get rid of the x in the denominator here. So I'm going to wind up with 2x squared, 60 because the x's will cancel, and then I'll have 20x. So if I wind up rearranging this, I'll have 20x squared minus 20x plus 60. And that will now be set equal to 0, which is what we wanted. And we'll divide through by 2. So that will leave you with x squared minus 10x plus 30 equals 0. And now I'm just thinking about how I'm going to solve this. So again, I'm thinking of my factors of 30, and might not work to factor. So let's go ahead and try another method. Again, I'll do completing the square. It's good practice for completing the square. Minus 10x. I'm going to need to add in 25, which means I will have 30 minus 25 outside of the brackets. So I'm really looking at x minus 5, quantity squared, and then plus 5. Now when I go to solve this, I'm going to be subtracting that 5. So here's where I'll subtract the 5. My next step would be to take the square root. So I now have plus or minus square root of negative 5. Tell me something. There should be a red light going off in your head right now. There is something wrong with taking the square root of negative 5. So I haven't even finished, and I've realized that I'm actually not going to get a real answer by doing this. So let's go back up to the question, make sure I did this correctly. It says, is it possible to bend a 20 centimeter length wire into the shape of a rectangle so that I have an area of 30? Well, I am figuring out, as long as I've done all my work correct, right, which it looks like we have, it is actually not possible because you're going to get a non-real answer. So no, it is not possible. So we'll write our sentence, and we will be finished. All right, go back and try all of these on your own, and have a wonderful night, and we'll see you in class tomorrow.